In this video, you are going to learn moment of force or turning effect of forces, a chapter of IGCSE O-level physics. You will be able to accomplish a firm grip on the concepts of turning effect of forces, and you will study about moments, center of mass and stability. I am an experienced online physics tutor and have done thorough research on these concepts of IGCSE Physics. So, let's begin turning effect of forces, our fifth chapter of O-level physics. Turning effect of forces. So, let me explain you what is the turning effect of a force. Whenever you apply some force to any object and it turns, it shows rotation or it rotates, that means that force is being converted into a turning effect, or that is being converted into rotating an object. Let's suppose there is a door. It's a door. This is the knob of the door, and here are the hinges. When you apply the force on the door in this direction, the door rotates like this. So you have applied some amount of force and the door has rotated. So this effect is basically the turning effect of force. Or another example, let's suppose there is a bolt and a spanner. This is a spanner. You are tightening this bolt with the spanner and you are applying a force F, and this bolt is being rotated like this. So this force has created a turning effect or a rotating effect. So whenever a force produces a turning effect or a rotating effect, so we call it as moment of force. Okay, so the turning effect of force is called the moment of force. Got it? Now, let me define you the moment of force with the formula. What is the formula for the moment of force? The moment of force is the product of force and the perpendicular distance from the point of rotation. So in these two examples, what will be the moment? This force, this was the point of rotation, so force multiplied by the distance from the point of rotation. Over here, this was force and this was the point of rotation, so force multiplied by the distance from the point of rotation. So we write the moment of force over here as moment of force is equal to force multiplied by perpendicular distance. Okay, the unit for the moment of force will be Newton meter. So this was the brief introduction of turning effect of forces, where we have defined the moment of force and given the formula for the moment of force. Now I'll explain you the principle of movements of a body in equilibrium. What is the principle of movement? Principle of movements for a body in equilibrium. There is the principle of movement for a body in equilibrium. What is it? In order to define that principle, let me explain you first the equilibrium. What is an equilibrium? When the resultant force and resultant moment of force on an object is zero, the object is said to be in equilibrium. When the resultant forces or the resultant force and the resultant moment of force on an object is zero, that means the object is in equilibrium. Let's suppose the object is stationary and it is not rotating, then it will be in equilibrium. Or an object is moving with uniform speed and is not rotating, then the object will be in equilibrium. Okay, so this was equilibrium for an object. Now what does principle of movement says? Principle of movements. Principle of movements. An object will be in equilibrium when the sum of clockwise movements will be equal to the sum of anti-clockwise movements around a pivot. So a principle of movement says that any object will be in equilibrium if its anti-clockwise moment is equal to the clockwise moment. I'll explain you over here how will the moments be equal and how the object will be in equilibrium. Let's suppose there is a rod and standing on a support. This support is, we call it pivot. There is some mass over here, some mass over here. Let's suppose this is mass m1, this is mass m2. Moreover, there are two more masses. This is m3 and this mass is m4. Okay, now the distance of mass m1 from this pivot, I call it O. The distance of mass m1 from O is d1. The distance of mass 3 from O is d3. From here to m4 it is d4, and from pivot to m2 it will be d2. So first of all we have to identify which is the clockwise moment and which is the anti-clockwise moment. This mass is exerting force over here, so the moment by mass m2 will be clockwise. Similarly, the moment by m4 will also be clockwise. The moment from m3 will be in opposite direction, that will be anti-clockwise, and the moment from mass m1 is also anti-clockwise. So I'll write the equation for this principle. Sum of clockwise moment is equal to sum of anti-clockwise moment. I write it over here. Sum of clockwise moments is equal to sum of anti-clockwise moments. Now the clockwise moment, this is clockwise, this is clockwise. So the definition of moment is, let's suppose the definition of moment is force into distance. So let's suppose this M4 is exerting force F4, this M2 is exerting force F2, similarly F1 and F3. So the clockwise moment, F4 multiplied by D4 plus F2 multiplied by D2. The moment due to these two masses is the clockwise moment, and the moment due to these two masses will be anticlockwise moment. So it will be F1 into D1 plus F3 into D3. So I write it over here, F4 D4 plus F2 D2 is equal to F1 D1 plus F3 D3. So while solving the questions, we will be using this principle of moments a lot, and the rest of the use of this formula will you will see in the solution of the past paper questions. Now after the principle of moments, we will switch on to the next concept, and that is center of gravity. Center of gravity. First of all, I define it, the center. What is a center of gravity? A center of gravity is basically a point on an object where the whole object exerts its weight, its whole weight. Okay, so that is center of gravity. A point on an object where it exerts its whole weight. That point of a body is its center of gravity. Let's suppose there is a rectangular board or a book. This book will exert its whole weight in the center. How will we find its center of gravity of a regular object? We will just draw diagonals. The point where these diagonals meet, this point will be the center of gravity of this object. Similarly, for a circular disc, its center of gravity will be its center. Okay, so this point will be the center of gravity for a circular object. Now what if there is an irregular object? How do we find its center of gravity? Center of gravity of an irregular object. Let's suppose there is an object like this. It's an irregular object. We do not know where will be its center of gravity. So what we will do, we will use a plumb line. We just first hang the object like this, attach a plumb line over here with its weight vertically downwards, and we will draw a line like this. Okay, similarly on some other point, let's suppose this was the initial line. Okay, now we will change the direction of this irregular object and hang it like this. This was the original line. Now we will attach the plumb line over here. Plumb line is basically a weight that is attached to a string. We will just attach the string over here, and the weight of the plumb line will be downward, so this will be a straight line. So we will draw a line over here like this. Similarly, at the end of drawing 3 to 4 lines, the lines will be like this. the point from which these lines will be passing, this point will be our center of gravity. So for this irregular object, this point is our center of gravity. Okay, so in this way we can find out the center of gravity for an irregular object, also for the regular object I told you earlier. Now we will discuss the stability, the concept of stability in this chapter. Stability is the ability of an object to come back to its original position upon disturbance. For example, let's suppose there is a rectangular block over here. If we disturb this block a bit, it will come back to its original position. Let's suppose there is cone. If we disturb this object by pushing with some force from here, it will tilt for a moment, and when we release the force, it will again come back to its original position. If we apply more force, this object might fall and this cone may or may not fall. Okay, now let's suppose we apply the force of 10 Newton on this object and force of 10 Newton on this object as well. By applying the force of 10 Newton, this object falls, but this object does not fall. That means that this cone is more stable as compared to this book or this rectangular block. So this is the property of any body to come back to its original position upon disturbance. A body that comes back to its original position after experiencing more force is more stable as compared to a body that does not come back to its original position by facing the same force. Okay, now what are the steps that we can take in order to increase the stability of an object? How do we increase the stability of an object? How do we increase the stability of a body or an object? How we can increase the stability of an object or body by keeping its center of gravity as low as possible. How will we keep the center of gravity as low as possible? Let's suppose I give you an example of a pedestal fan. This is a pedestal fan. This is its base on which it is standing, and this is the fan. Now this fan is more stable. It's a stable object. Why? Because most of the mass will be in its stand, that is on the ground. This base is quite heavy as compared to this upper portion, so its center of gravity is more close to the ground, so this fan is more stable. Moreover, so this was the number one step. We can increase the stability of an object by keeping the center of gravity as low as possible. This is the number one step by which we can increase the stability of an object. Number two is we can increase the base area of the object. when the base area of the object is more, the object will be more stable. Let's suppose the racing car. The racing car, like this, it has more base area. So any object that has more base area and the center of gravity will be as low as possible, that object will be more stable as compared to an object which has less base area. This is the reason that in a double-decker bus, more passengers are on the lower deck as compared to the passengers on the upper deck. So base area should be as low as possible, as low and so not low, base area should be as wide as possible. Okay, so by keeping center of gravity low and keeping the base area of the object as wide as possible, you can increase the stability of an object. So this was all from chapter 5 of O-level IGCSE Physics. If you have any confusion regarding these concepts, just to comment in the video. I'll explain you everything over there. Moreover, wait for my videos of the past paper solutions. I'll be solving all the past papers of IGCSE O-level Physics. Thank you.